Hello and welcome to my first Dwarf Fortress guide. This is a machine I've made, a semi-automatic obsidian generator. Why would you want this? Well, if you can pump out as much obsidian stone as you could possibly ask for, it's pretty useful. It's a high-value magma-safe stone. I'm using it here to pump out mechanisms, make other rock items, and of course blocks. If you have a big project that you want to be made out of obsidian, you're going to need a lot of it. And here in Doom Furnace, we're making this large octagonal tower. I'm going to do other things. I had a fort in the past that I had a manual obsidian generator, and if you have a big project, as in high obsidian block count requirement, it gets tedious. So that's why I've made this, and that's why I'm making a guide for it. What do you need? Well, you need a water source and a magma source. Here, I've probably got the worst of both. I'm using these six water reactors, which are an FPS tool, to pull magma from the magma sea using a pump stack. By the way, if you can pump from a level on the magma sea that's lower than the surface level, like the lowest level, you'll get much more volume. And for water, I've got this reservoir here that's filling from a light aquifer I've tapped. So we have a light aquifer here, and that just slowly fills up the reservoir. This is probably the worst option if you have a large river or an ocean or a heavy aquifer or can pull from the cavern lake. That's going to be better. Basically, the more water flux you have, the better. The whole machine should be at the bottom of the water reservoir. The reason for that is that you can avail of full water pressure at all the time. So that this, which is the top of the casting chamber, can always be immediately refilled, and you don't have to wait for water to slowly flow in. You get the pressure to push it on immediately. There's a visual bug here. There is water over this bridge. This is a retractable bridge. If you haven't used one, it's this here. So water's on this, and we have this bridge as well. They're both connected to the same pressure plate, so that one signal will close this bridge and open this one, meaning all the water here, 16 by 16 cubes of 7 out of 7 water, will drop, and no more will flow on. Why do we want that? Well, the magma, when we initiate, flows into this chamber, fills it up, and then the water falls down on top of it. Let's see it in action. I have a dwarf set to pull this lever. This lever isn't actually connected to anything. It's this pressure plate, so we can have a short pulse. It hits the switch. This switch, I'll go over these switches, is controlling the inlet valve, this bridge and this bridge. So it has an on state and an off state. The on state is when this red pressure plate is showing, the bridges are open. The off state is when the black one is showing and they're closed. The last square to fill in this casting chamber is this one, the very corner, on which we have another pressure plate that triggers only when it's at 7 out of 7 magma. Good to pause here briefly. That pressure plate is connected to this switch. This switch controls the state of these 3 bridges. So here's the neutral state on the layer above. We have open, closed, open. So when that's activated, the front and the back one close, and the middle one opens. Which means, because the front one closes, we seal off our 16 by 16 cast chamber, which is important, and we can also let magma flow onto a second pressure plate, which triggers at 2 through 7 out of 7 magma. And the reason that's useful is that we can have a delayed signal, right? So we have this signal doing a couple things, and then shortly afterwards we have another signal. So as I said, this controls the state of the bridges. This is like state 2, this is state 1. So it hit the switch, it's going to state 2, and it also hit this gear here. What's going on here is we have another switch here that's controlling the water. This array here is a big OR gate. So on the south side we have power coming from the water reactors. On the middle row, these are our inputs. I'm only using 3. And if any one of these gears is powered, then power is sent from the south to the north row through. And that's going to hit this switch. And what that switch does is drops the water. It opens the big gate, the big bridge, and closes this one. Dropping water very satisfyingly onto the magma square. The other thing about this water switch is that it resets itself. So as soon as this OR gate is powered, this gear is powered, powers this roller, powers this minecart, which lands on this pressure plate, controls those bridges, and also powers this gear assembly, which is this is just power here, which powers these 2 rollers and sets this minecart going. This track length is a little bit arbitrary. The point of this is that it resets itself, right? So this minecart goes back to its original position, gets powered here, goes along, hits a pressure plate, falls back to its original position. This pressure plate is connected to the switch that controls the water bridges to reset it back into its original position. So now we see that open. And because we're at the bottom of the water reservoir, it's already completely filled with water. That's the pressure we're dealing with. The other thing this second switch does is closes the inlet valve on the original layer, so that when we dig out the obsidian, your miners are safe because the bridge is closed. Finally, opens the inlet valve on the layer above. So we have magma pumping in, and we have the same setup here, basically, and you can do as many layers of this as you want. I have 16 by 16 here, which you can see we're running out of pressure, right? So maybe 16 by 16 is too big to be optimal. Maybe if you have more pumps, it's going to be faster. Maybe if you pull from lower in the magma sea is what I should do. If you pull from a volcano, obviously that's going to be way better. Is that not just so satisfying? Beautiful. This little square here, this is just a drain. I don't think you really need it. Just a bit of space for the magma to decay. Don't worry about this. Nothing dodgy happened there. I'll go over these switches now. Okay, so each pump stack level has a switch. You know what? We can just go over this one here. Here's one I built. This does nothing. So you have power coming in. You have 2 blocks with 4 squares, 2 walls with 4 squares between them. The 4 squares between them must have tracks. A roller going max direction east on the east of the west block, and similarly max speed west. Now, then we have 2 pressure plates. I have a black pressure plate and red pressure plate that are triggered on minecarts. So you don't need all of these levers for every iteration of this switch. This is called a Newton's Cradle minecart switch. What's cool about it basically is that it has 2 states, right? Here's one state, the other state is, well, also forbid these. One state is when the black pressure plate is depressed, and the other state is when the red pressure plate is depressed. Like so. You may not need both pressure plates. You might just need one pressure plate, you know, a signal from that. When the switch is in state 1, it's going to be on. When the switch is in state 2, that's going to be off. You don't need all the levers either. This lever is connected to this gear assembly, this one to this one, each of them to their nearest gear assembly. This one is like to arm or disarm the system. If I pull this, then there's no power to any of them. But you're not controlling these 2 gears. These gears power the rollers. You're not going to control those with levers typically. You're going to control them with pressure plates. So that's what I've been doing. Let's check back on our project. Yeah, it's completely filled. So like these pressure plates, yeah, can send a pulse, and that's all you need. You don't need a constant signal. You can send a pulse to this gear assembly, powering the roller, powering the minecart. The minecart goes across, lands on the pressure plate, hits the other minecart, takes it off its pressure plate, and then that is, you know, the second state, as it were. I'm just going to briefly go over how to set up the hauling routes to make this Newton's Cradle minecart switch work. Shift H to open hauling in the Steam edition. So you need 2 routes for this. Make one. We'll add a stop. So you're going to have 1 stop for each route. I'm going to put 1 on the black pressure plate. Add a new route. Add the stop, and I'm going to put the other stop on the west rollers. So it's important that 1 stop is on the edge and 1 stop is on the middle, with a space between them. You could also do a stop on the red pressure plate and the eastern roller. So let's add some minecarts. That are not being used by anything else. Remove the conditions. And name them. Especially if you're going to do a few of these switches. It's important that you're able to find your way through them. So test, switch, east, test, switch, west. So your dwarves will move the minecarts onto it. They're not using this one. I guess I picked the wrong one. Make sure there's no power going to these gear assemblies, as you have your dwarves put the minecarts on, otherwise they might get run over. In fact, we could use this disarming switch. So when they're on, forbid them. You want them forbidden, otherwise your dwarves will try to replace them back onto their roots, onto their stop. But we don't want that. And that's that. So each layer has one of those to control the inlet valves of the magma. And then there's also one for each of these bridge arrays to have two states. Like I went over, open, closed, open. And then the other state is closed, open, closed. And then, since there's two switches, you can have one to change the state. The magma flows in, hits it, can change state. When it changes state, hits the second pressure plate, which resets it back to its initial state, in addition to providing pulses for dropping the water and closing the inlet valve. So here, we can set our dwarves to mine this out. Use channel mining. And I think that's everything. What have I not covered? That looks like everything. Yeah, so there you go. I'm not sure how much obsidian I get out of this. I think it's about 200 or 300 per cycle, which is cool. Let's look at our reservoir. Like, mine is pretty empty now, which is why I'm only using 3 layers. Get lots of miners as well. So there you have it. Strike the earth, find the magma, turn it into obsidian.